You've probably heard the legends. They call them killer ants, a terrifying living river of death flowing through the African tropics. We're talking about driver ants, and their reputation is, well, the stuff of nightmares. But is any of it really true? And look, this isn't just some old campfire story. It's a persistent, chilling legend you'll find whispered all across the internet. I mean, the thought of something so small but so overwhelmingly numerous and aggressive, it kind of taps into a primal fear, doesn't it? But believe it or not, the truth is way, way stranger. Get this. Their jaws are so incredibly strong, their grips so unbreakable, that people like the Maasai have used them for centuries as living stitches. I'm not kidding. You get the ant to bite across a wound, you snap off the body, and the head just stays there, locked in place like a perfect clamp. It's just a wild example of nature's brutal, but also brilliant ingenuity. But myths and, frankly, gruesome medicine aside, this is what they truly are, a relentless flowing river of life, always on the march. So it makes you wonder, right? Where did an incredible, highly specialized creature like this even come from? The answer, as it turns out, was a major scientific surprise. To really understand the driver ants, we have to look past all the terror on the surface. And, well, we literally have to dig into its deep past. And what a story it is. It takes a turn you would never, ever expect. So here's the puzzle. When you see a predator this specialized, you just assume its evolution was a straight line, right? Always getting better and better at hunting on the surface. But nope. The genetic evidence tells a completely different story. And here it is, the first big twist. The common ancestor of all these terrifying surface raiders wasn't a raider at all. It was an inconspicuous, kind of boring subterranean species, living its entire life in the dark, deep under the soil. Their evolutionary journey is just fascinating. So from those underground ancestors, one group moved up a level, into the leaf litter, a much more complex world. Then came the Great Split. One lineage continued its ascent, becoming the famous surface-raiding driver ants we know today. But another group did something remarkable. They did a complete 180. They turned around and went back underground, re-evolving a fully subterranean lifestyle, just like their distant ancestors. And hey, this wasn't a quick pivot. This whole genetic drama played out over tens of millions of years. Their story starts with that common ancestor underground, maybe 45 million years ago. The move up into the leaf litter happened around 30 million years ago, and then, about 23 million years ago, that's when the Great Split happened, sending one group back down into the earth and the other out onto the world stage. Now, these dramatic lifestyle changes weren't just a choice. It's not like the ants just decided to move. No, evolution had to completely re-engineer their bodies for each new battlefield. I mean, think about it. The kind of body you need for hunting in narrow soil tunnels is completely different from the one you need for swarming across the open forest floor. Their entire anatomy, their whole toolkit, had to adapt or they would have just perished. And this is where it gets really cool. The surface swarmers, they evolved long legs for speed and these huge jaws for battle. The original underground ants had short legs and small jaws, which are perfect for tunnels. So what about the group that made that U-turn? They re-evolved short legs and small jaws, ending up looking remarkably similar to their ancient ancestors. It's this stunning example of what's called convergent evolution, when two totally different paths lead to the exact same solution. So we've got the bodies, we understand the hardware, but what about the behavior that makes them so legendary? Let's talk about the endless, epic march of the driver ants. See, unlike most ants you might find in your garden, army ants don't build permanent homes. They live in a constant state of motion, a lifestyle called nomadism. Their so-called nests are really just temporary bivouacs, living camps, in an endless campaign for food. And the sheer scale of this operation is just mind-boggling. The average width of a single hunting swarm is about 10.3 meters. That is over 30 feet wide. Just try to picture a dense carpet of ants that wide, a living tide sweeping through the forest, consuming nearly every single invertebrate in its path. And when they've stripped an area bare, the entire colony, and we're talking hundreds of thousands of individuals, just packs up and moves. Their average migration to a new nesting site is almost the length of a football field. So, why the constant motion? Well, it all comes down to one thing: food. A single swarm can devour everything in over 1,000 square meters in a single day. So to survive, they have to keep moving. They strategically avoid areas they've recently hit, and they even steer clear of their neighbors. It's the ultimate mobile resource management strategy. This incredible evolutionary story didn't just give us a new origin for the driver ant, it completely forced scientists to rewrite their family tree. For a long, long time, scientists classified these ants based on what they look like, their morphology. It makes sense, right? But the DNA, well, the DNA told a much more complex story. And it proved that the old family tree, the one based just on appearances, was flat out wrong. The old idea was simple, a one-way street from underground to the surface. Clean and tidy. But the new reality, backed by genetics, is a tangled, branching path. We now know that the different groups of surface and underground ants are not these neat, separate lineages at all. In fact, some surface hunters actually gave rise to new underground species. It's just a powerful reminder that evolution doesn't always move in a straight line. And this brings us to a final, really fascinating thought. The true story of the driver ant was this huge surprise, hidden away in its genes. So it makes you wonder, if we were this wrong about one of the most infamous insects on Earth, what other incredible stories of adaptation, reversal, and survival are just waiting to be discovered, literally right under our feet?